Hi, we're going to discuss point mutations today. Point mutations are when a single nucleotide base is changed, inserted, or deleted. We're going to use this DNA sequence as an example strand, and we're going to use it because of the two sequences highlighted in color. The ATG is the start codon, and the TGA is the stop codon. And so that's going to tell us when to start and stop transcription. The mRNA sequence is as below, and the amino acids are as well. We're going to start with a missense mutation. A missense mutation is when one base pair is changed and it's going to alter the original DNA sequence. It's going to result in a codon which codes for a different amino acid than what was previously there. So we originally had TGG and we changed it, or it was changed to an AGG. This change from a T to an A is known as a transversion, and a transversion is going to be when the nucleotide base is changed from pyrimidine to a purine or vice versa. So this is going to result, this change from a T to an A in amino acid, and now it's an arginine. So this can either result in a non-functional protein, a semi-functional protein, or a fully functioning protein. Alrighty, and so for a nonsense mutation, we changed here the C to an A, which is also a transversion, and it's going to change the cis amino acid to a stop. So what happens here is the protein is going to be stopped suddenly. It's going to be cut in half. It's going to be shortened, and it's most likely going to be non-functional. A way to think about this is you have a sentence and you have a comma in it, but you suddenly change it to a period. Suddenly that sentence is two sentences, and they might not be functional together because they're like separated now. Silent mutations are when one base pair is changed, but it won't change the amino acid it codes for. So here you can see this is an ATC. Originally it was an ATT, but both of them still code for this LLE or IIE. So the amino acid should, or the protein strand should be completely fine. It's a transition from C to T or T to C because they're either both purines to purines or pyrimidines to pyrimidines. The way I like to think about it is using the analogy with tape and superglue. Even though they're different like items, they still will get the job done in the same. And so even though you change the C or the T, it's still going to code for LLE. Alrighty. And then we have a read-through mutation. It's when the stop codon is mutated to where it produces an amino acid and the protein strand continues on longer than it should have. For our example, you can see here that the UGA is changed to a UGU. So it's going to change the stop codon to a cis. And the chain is now able to continue on until the next stop codon appears. This is an example of a transversion because it's changing the A to a T. We can use the comma and period analogy again, except switch it.